Kinetic molecular theory of gases. The molecule details about the gases can be visualized with the help of a theory called the kinetic theory of gases. This attempts this theory attempts to elucidate the behavior of the gases and also provide a microscopic model of gases. The main assumptions of this theory are as follows. Gases are made up of large number of identical tiny particles, atoms, and molecules which are so far apart that their actual volume is almost negligible as compared to empty space between them. That's why they are considered as point masses. This assumption explains the compressible nature of the gases, the intermolecular forces of attraction between the particles of a gas at ordinary temperature and pressure are negligible. That's why gas expand and occupy all the available space. Particles of the gases are always in a state of constant and random motion. That's why shape of gases is not definite. The particles of a gas move in all possible directions, stabilize and collide with each other and also with the walls of the container. Thus, they exert some pressure on the wall of the container pressure and equal to number of collision per unit time per unit area by the molecules of the wall of the container. Collision of the gas molecule are perfectly elastic. There is no loss of energy or total energy of the molecule before and after the collision remains the same. At a given temperature, the speed of different particles in a gas are different. However, at a given temperature, the distribution of speed remains same. At a given temperature, the speed of different particles in a gas are different. However, at a given temperature, the distribution speed remains constant. As the gas molecule has variable speed, it also has a variable kinetic energy. In this case, we take average kinetic energy. It is directly proportional to the absolute temperature. Kinetic energy directly proportional absolute temperature equal to 3 by 2 kBT, where kb equal to RA by NA, and the Boltzmann constant at the absolute zero t equal to zero. Kinetic energy of the gas becomes zero. Thus, the thermal motion of the molecule is expected to see at its temperature. Above relation so that K of gas is independent of its nature, pressure, and volume of the gas, but depends only on the temperature. This is known as Maxwell generalization. On the basis of postulate of kinetic theory of gas, the following gas equation was derived: Pb equal to 1 by 3 m and U square. This equation called kinetic gas equation. P equal to pressure exerted by the gas, B equal to the volume of the gas, and equal to number of molecules. U square equal to root mean square velocity of the gas.